Friends, how are you all? Welcome in this session. Students, in our previous session we had discussed about the classification of organic compounds, and today we are here to study the homologous series. We know that the series of organic compounds where the successive members follow a regular structural pattern and successive compounds differing by CH2 groups. That series is called the homologous series. The general characteristics of members of homologous series are they are same in functional group and general molecular formula and the chemical properties, and in molecular weight when moving down a series, molecular weight of two adjacent members, it differs by 14 due to the CH2 group increases, and in physical properties it increases when moving down in a series. It gradual gradation seen with increase in molecular weight, example BP means boiling point and solubility. Now significance of homologous series. What is the significance? So actually it helps in the systematic study of organic compounds, and it predicts the properties and nature of other members of the series if the same is known of the first few members. Now homologous series by hydrocarbons. The term hydrocarbons aliphatic open chain organic compounds containing carbon and hydrogen only. The molecular formula is CXHY, where X and Y are whole numbers. The two main groups of hydrocarbons, that are saturated hydrocarbon and unsaturated hydrocarbon. In saturated hydrocarbon, carbon atoms joined by single covalent bond, whereas in unsaturated hydrocarbon there will be double or triple covalent bonds. Example of saturated hydrocarbon is ethane, methane, propane, and unsaturated hydrocarbon is alkene, alkynes. That means ethene, ethynes. Now homologous series, you are seeing here the normal formula of alkanes are CnH2n plus 2. If N is 1, so H is 4. If N is 2, H is 6. Here it is given. Now in alkenes, normal formula is CnH2n, and in alkynes CnH2n minus 2. These are the members of alkene family, and members of alkyne families are given here: ethyne, propyne, butane, and pentyne, and etc. Now preparations. Now how they represented. This is the representation. Organic compounds are represented by molecular formula and structural formula. So molecular formula indicates actual number of each kind of atoms in a molecule of organic compounds. Example ethane, ethyne, ethene, etc. And structural formula indicates the arrangement of various atoms in a molecule of the organic compound. It is a more informative formula, represents condensed structure and branched structural formula. Now alkenes, you know the molecular formula and structural formula. Here ethane in alkanes, ethane, propane, butane. This one is molecular formula, but structural formula is given here. This one is the structural formula of ethane, structural formula of propane, and structural formula of butane is given here. Now alkenes. Alkenes, they are double bonded, so double covalent bonds are there between the carbon. First example is ethene, then propene. This one is molecular formula and structural formula is given here. Now next alkynes, there will be triple bond. So alkynes, example methyl, acetylene. This one is also the example of alkynes, and butynes is given here. Now condensed structural formula also shows alkyl groups and functional groups. Now first is alkyl group. All groups derived from parent alkanes by loss of hydrogen atom, and parent alkane that are methane, and in alkyl group methyl, then ethane, ethyl, and propane. When it loses its electron in one hydrogen, it form into propyl. Now butane, it converted into butyl by losing its one hydrogen. Now functional group, an atom, radical or bond which define the structure of organic compounds and confirms the characteristics properties to it. Now functional group and organic compounds are given here. So OH represents the hydroxyl group, and CHO represents the aldehydic group, COOH represents the carboxylic group, and chlorine, fluorine, bromine, iodines are halogens. So here when OH will be there, this one is called the methanol, this one is called methanol, and SCOOH is called methanoic acid. That means COOH is it, you can read as a oic acid, and CH3Cl chlorine, that means chloromethane. And instead of chlorine, if there will be bromine, it will call the bromoethane, bromomethane, bromopentane. So here this one is bromochloromethane and this is bromoethane. Now term isomers and organic compounds having same molecular formula. So what are the isomers? So isomers are the organic compounds which having same molecular formula but differing in molecular arrangement or in structural formula. That means the compounds which have same molecular formula but different structural formula, they are called the isomers. Now characteristics of isomers, this phenomenon is called the isomerism. Now properties, number of isomers, types of isomers, this is also important and we will discuss about it in our next video. Till then, thank you.